All right, as we start studying inequalities now, the gist for solving is about the same, but it'll involve some graphing, and the reason is that inequalities all have an infinite set of solutions. So for example, if you solved an equation, you might get an answer like x equals 2. That's it. That's the answer. One number, 2. If you solve an inequality and you got an answer like x is greater than 2, that means any number in the whole universe that is bigger than 2, like 3 and 4 and 2.7 and 800 and anything not 2, because 2 is not greater than 2, but any number bigger than 2, anything in this direction would be a solution. So it's going to involve graphs because we don't want to list all of the numbers that are greater than 2, but we can show a picture saying, all right, anything this direction with an arrow on it, meaning I go forever. Okay, so a couple things to watch out for, and we will go over those now. So let's discover something here. This says 4 is greater than 2. So first of all, you want to make sure you know your symbols. This one says greater than, and this one says less than, so that when you're reading it with variables, you'll know what it says. So 4 is greater than 2. That is true. 4 is greater than 2. Now we're going to add to both sides of this. We're going to add 2 to both sides. So this is kind of like an equal sign. Adding 2, so we're keeping it balanced. Now we have 6 is greater than, don't change this symbol, is greater than 4. 6 is greater than 4. Still true. Okay. So we can add to both sides of an inequality and it keeps its trueness. So we need to make sure everything stays true. Now we could minus 2 from both sides. Let's see what happens. So we would get 2 is greater than 0. 2 is greater than 0. Still true. So we can subtract both sides and it still stays true. Now let's multiply both sides. So times 2 times 2. We would get 8 is greater than 4. 8 is greater than 4. Still true. So we can multiply to both sides, just like we did with equations. Stay true. Now we'll divide both sides. So 4 divided by 2 is 2 is greater than 1. Okay. 2 is greater than 1. Still true. All right, so we've added, subtracted, multiplied, and divided. Now, adding and subtracting positives and negatives works the same way. You still slide left for minusing and right for adding. But when you come to multiplying and dividing with negative numbers, you know that sometimes that changes the sign, right? Depending on what kind of number you started with. So let's look at this. Let's multiply both sides of this by negative 2. So negative 2 and negative 2. So we would end up with a negative 8 is greater than negative 4. Let's look at that. 0, 1, 2, 3, negative 4, 5, 6, 7, 8. Nope. Negative 8 isn't greater than negative 4. It's to the left of it, right? Things are smaller this way and bigger this way. So this is false. In order to make it true again, what would we have to do? What would we have to do to this statement to make it true? We would have to reverse or flip the symbol, the inequality symbol. So it'd have to say negative 8 is less than negative 4. That would be true. All right, now let's see if we divide by a negative 2. We would have negative 2 is greater than negative 1. Negative 1, negative 2 is not greater than negative 1. This is false. In order to make it true again, we would have to reverse the inequality symbol. Flip it. So it would have to say negative 2 is less than negative 1. Now that would work. Okay. So that was interesting. It stayed true when we added, subtracted, multiplied by a positive, divided by a positive. But when we multiplied or divided by a negative number, it became false. We have to make sure things stay true. So, what did we learn? This is a really important rule. When you multiply or divide by a negative number, you must reverse or flip the inequality symbol. The reason I'm not saying sign, flip the sign, is that sign technically refers to positive or negative. You're not changing any signs, you're changing a symbol. This versus this. No, those are both the same. This versus this. Which one's less? Less. Greater. If you're having trouble, sometimes I tell people the one that kind of looks like a squashed L could be less. So it's less. Okay, so if you want to add anything to your card, if you're using a card, same 5 steps. But on this very last step, make sure you reverse the inequality symbol on that very last step if you're dividing by a negative. So if the variable has a negative number with it and you're dividing, you're going to have to flip the inequality symbol. Let's take a look at how that might work. Okay, so we want to compare these two. If I have 3x is less than or equal to negative 12, we'll divide by 3, and we'll get x is less than or equal to negative 4. Okay, we don't flip anything because we divided by a positive number. The variable was positive, so it's what you divide by. So this would mean that x would be anything 1, 2, 3, 4, including, so shaded in, negative 4 or below. This one, we're dividing by negative 3. So, dividing both sides by a negative. So, flip. We have to flip that one, okay? So, x is greater than or equal to negative 4. So this one would be when you have to flip because we divided both sides by a negative number. You see the difference? Doesn't matter if there's a negative here. That doesn't matter. This number can be any sign, positive or negative, but what you divide by. So what was with the variable on that last step is what controls it. So this one would be 2, 3, 4 negative, including that, but anything greater. So we're talking about anything this direction. Okay, now when we compare these two, this would almost never happen because we never usually see a negative down here. But if it did, here's the difference. On this one, we have to x divided by 5, so we have to multiply both sides by 5 to get rid of the division, and x would be greater than negative 10. Done, okay? X is greater than negative 10. By the way, solution set will look a little different since it's more than one thing. It'll be the set of all the x's where x is greater than negative 10. Instead of just a 10, it's the set of all x's where x is greater than negative 10. And on a graph, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 10, not included because it's greater than, not equal to, just greater than, so that'd be this way. All right, this one divided by negative 5, so we're going to have to multiply both sides by a negative 5. If we multiply or divide both sides by a negative, we have to flip the symbol. So this is going to flip. So now it flipped. So it has to do with multiplying or dividing by a negative. So this would be the set of all x where x is less than negative 10. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 10, not including it, but going anything less than, so that direction. Okay, To do set notation up here, this one would be the set of all x where x is greater than or equal to -4. So it's still a set, there's just more than one number. This one would be the set of all x where x is less than or equal to -4. All right, so that's a couple things to notice the differences between. And then we want to make sure the variable is on the left side at the very end, and it's for graphing. That's why, so that when we get to graphing, it won't be so confusing. So when we do this one, we're going to -3 from both sides to get r isolated. So we have r is greater than or equal to -1 minus 3 is -4. So this says -4 is greater than or equal to r. Okay, now we don't change the meaning, but we read it from r's perspective. If -4 is greater, this is the big side, right? If it's greater than r, and we have to write it with r on the left side for graphing, make sure we don't change the meaning. See the little end on the r? So make sure the little end is still on the r. So these two things mean the same thing, okay? But we want this version, okay? Because otherwise, when we go to graph it, if we read it this way, we're going to think this says greater and we're going to go to the right. But what it actually says is -4 is greater than r, which means that r is less than or equal to -4. So this one will go this way. That's why we always want to make sure variables on the left. So we can solve with it on the right. We'll divide by 2, divide by 2. So we get -3 is less than a. But we want to, what does that really mean? Well, a and -3, what's their relationship? -3 is less than a, so the big side is on the a, so it means this. So when I go to graph it, 0, 1, 2, -3, not included because it's not equal to, but it's greater, so it's going to go this way. If we don't take the time to write it with a on the left side, then we're going to read this less than sign and we're going to accidentally graph the wrong way. All right, so here's another one. Now this one has a couple tricks to it, a couple little steps. It's harder than it looks. So -2 from both sides. Okay, so -4 minus 2 more is -6. Bring down my symbol, but I still have -c. So remember, that means we have to divide by -1 because we could pretend there's a -1 there, and there is, but we could make it visible if we want. So, but watch out. What we just did is we just divided both sides by a negative, so we have to flip it. Okay, so not a big deal. Negative divided by a negative is positive. And now we have this, okay? But remember, we want it with c on the left. So if 6 is less than c, c is on the big side, then this is what it really says, okay? So we have to be careful. It's kind of, it might feel like a double flip, but this part here, this isn't a flip. This is the same. This is the same. It's just reading it from the other side. These are the same. So let's see, the graph will look like 0, 1, 2, 3, 4, 5, 6, not included, and greater than that, so go in that way. All right, the last one here, we've got divided by -3, so we'll have to multiply by -3 to get rid of that. But we're doing, get some space here. We're doing a negative number to both sides, so this is going to have to flip. It was less than, so now it's greater than. Okay, watching out for that. Now, making sure that we rewrite it with the variable on the left, x and -9. Big end is on the -9, so big end on the -9, little end on the x, so it's saying this, and it has equal to. So when I go to graph it, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's included because it has equal to, so we'll shade it in. And it's less, so it's going to go this way. Okay. All right. So you can try your assignment and see how it goes. Just make sure that anytime you do any work that you are checking it, because half your job is to do it, the other half is to check it. If you don't know if it's right and you assume you're right and you're making little mistakes, then you're not giving yourself a chance to fix them and you wasted your time. Don't do that. Let me know if you need any help. You can do it.